Hello, we will be teaching you how to convert an augmented matrix to reduced row echelon form. So here are two matrices. To reduce row echelon form, it must satisfy the row echelon form conditions, which are the first non-zero element in each row, called the leading entry, is 1. Each leading entry is in a column to the right of the leading entry in the previous row, and rows with all zero elements, if any, are below rows having a non-zero element. So this matrix satisfies these three conditions because in each row, the leading entry is 1, and each leading entry is in a column to the right. So like this row, the next leading entry is to the right of the previous row. And then if the row has all zero elements, which we have here, then it's at the way bottom. So the reduced row echelon form must satisfy these three conditions, but they also need to have the leading entry in each row to be the only non-zero entry in its column. So the difference between these matrices is that this has number 3 above the leading entry of this row, while all of these leading entries have no numbers above or below the row.
Okay, and then in order to get the augmented matrix into our reduced row echelon form, we want to follow this algorithm. So first, our leftmost non-zero column is the pivot column, and pivot position is at the top. And so if necessary, we want to swap the rows so that the pivot is non-zero. And then we want to use row replacement, so that's like adding a multiple of one row to another to zero out entries below the pivot. And then you want to cover up this row and all the rows above and repeat for the other rows until you're done with all the rows. And then to get it to reduce row echelon form, you want to scale the rows so that the pivots are 1 and 0, and you want to zero out all the entries above the pivot, just like we showed in the example above. And so we want to use these three main methods: substitution, which I just explained, multiplying a row by another, or multiplying a row and then subtracting or adding it from another. You can also swap the rows, and then you can also multiply the full row. So we have an example of a matrix right here: 1, 2, 3, 4, 5, 6, 7, 8, 9. We first want to look at the row below, and we want to zero out this entry right here because it's below a pivot. So in order to do that, we're going to take row 2 and subtract it by 4 times row 1, which is going to get us 1, 2, 3, 0, -3, -6, 7, 8, 9. We also want to do the same for this 7 right here, since it's also below this 1. So you're going to take row 3 and subtract it by 7 times row 1. And then we're going to get 1, 2, 3, 0, -3, -6, 0, -6, and -12. And once you look at this matrix right now, we can also take row 3, and we notice that's a multiple of row 2. So we can zero out this whole bottom row to get 1, 2, 3, 0, -3, -6, and all zeros, and we can keep this row at the bottom. And the next step, we also want to turn this -3 into a 1. And in order to do that, you can just divide row 2 by -3 to get 1, 2, 3, 0, 1, 2, and all zeros at the bottom. And now in order to get to RR, or row reduced echelon form, we want to zero out this entry above this 1. And in order to do that, you can take row 1 and subtract it from 2 times row 2, and you're going to get a matrix of 1, 0, -1, 0, 1, 2, and 0, 0, 0. And this matrix fulfills all the requirements for our REF form.